Hi friends, welcome to lesson 19. Today is gonna be a short video. Okay, so it's about theorem number 2. I hope you remember theorem 1. Without referring, can you remember what is that? Can you read it out? What is theorem 1? If you can read it out, you remember, well done. If not, you can go and refer and recap again what is theorem 1. And today we're gonna add on theorem 2. Okay, look at my cute apple. When was your last time eating apple, huh? Go to your fridge, go get apple if you have it. Okay, please munch and eat it because apple is good for your health. Okay, so let's check out previous lesson homework. Okay, let's go. So previous lesson was about theorem 1. Okay, perpendicular bisector of chord. Perpendicular bisector of chord passes through the center. Okay, passes through the center. Theorem 1, we recap again. Okay, so let's look at your exercise 3.1. Okay, number 1 A, B, C, A, B, and then number 2 A, B. Let's double check again. I've marked your work in your PDF. When I return back to you, you open the PDF and double check again if there's any changes. If there's no changes, please message me. I will send you the PDF file that I've already marked. Okay, just in case if it doesn't sync with my OneDrive. Okay, documents. Okay, so number 1 AB, number 2 AB, please mark. I think most of you get the answers. Okay, number 9. Number 9 AB will be 37. I think this one, no problem for you also. And then B is 420. Okay. This one, I think I revised with you a bit. Okay, your R, okay, basically I already draw this out for you. This triangle over here, I draw it out for you here. Okay, so your hypotenuse is R, your 35 is your A, and your B is R minus 25, and you solve this one. This one is basically same with the try it number 1. Okay, and then as your half base height, okay, your base is 70 here. Okay, 70. And your height is this one, which is your R minus 25. So your R is 37, you already found it here, minus 25, so your height is 12. And then therefore you get 420. Okay, please take just in case if I mislook your answers. Okay, please double check again. Right? Alright, theorem 2. Today will be theorem 2 only. Alright, so please fill in this one to your 9 circles that I have asked you to draw earlier. Okay, in your first page of your new topic here. Okay, so new theorem number 2, equal chords are equidistant from center. Okay, chords again, chords is these green lines. These green lines are called chord. Okay, are equidistant. Equidistant comes from the word equal distance. Okay, equal distance. Equal and distance. Okay, from the center. So, these equal chords here, you see the green lines here, right? Okay, these red lines, okay, they are called perpendicular distance. Okay, they are called perpendicular distance. So if you have equal chords, this green chord and this green chord, if they are the same length, okay, so they are equal distance from center. This distance and this distance will also be the same. Okay, now you look at this. Okay, this chord and this chord, they are the same length. Okay, if they are the same length, then this is a perpendicular distance. It's a 90-degree perpendicular and a perpendicular. This perpendicular distance is the same. You see this 3.61. Okay, what if I move a bit? My chord lengths are still the same. Okay, the chords, both chords are still the same. And if the chords of the length of the chords are the same, so the perpendicular distance are also the same. You see this 3.61. Okay, if I pull it longer, for your chord, the perpendicular distance will become shorter, and it's also the same. They are the same. Okay, look at that. Okay, so this is your second theorem. Okay, so let's look at try it 3. Okay, let's look at try it 3 here. Okay, so in the diagram, O is the center of the circle with radius 13 cm. Okay, so the radius is 13 cm and it's not stated in this diagram. It's on the question itself. And AB equals to CD equals to 24. So AB, CD, these two chords are the same length. Okay, you see this one tells this part over here tells you that these two lengths are the same. These two chords, and the radius is 13 cm. Find the length of NM. So NM are perpendicular distance. OM perpendicular distance. ON is also a perpendicular distance, and they are the same according to your second theorem. This and this will be the same. okay? And then your radius is 13, meaning to say that this is 13, this is also 13. Okay, radius ma. The radius is everywhere from center to circumference, okay? So this one is 13. So ABCD is 24. So since it's a 90 degree, we know that from theorem 1 that these two lengths the same. So we break it into half, which is 24 divided by 2 is 12. Okay? So if here is 12, 12, here is also 12, 12. Okay? Because these two chords are the same length. Okay? So we have 13 over here. So basically ON and OM, they are the same. Okay? So we find OM first lah, or ON. It depends on you. Okay? If me anything lah actually. OM, I will find OM using Pythagoras Theorem. Okay? If you can see this triangle, this is a triangle where your O, M and B 90 degree, 13 and 12. So I find my OM using Pythagoras Theorem. So OM will be square root of your hypotenuse square minus 12 square. Okay, so here I will get 5. Okay, this is 5 centimeter. So OM is 5. ON is also 5. So therefore, our N to M will be 5 times 2, which is 10 cm. That's it. Easy, right? Okay, as long as you understand the theorem, okay, then you can do it. Okay, so let's go to question straight away. Okay, this is exercise 3.1, page 91, number 3, A and B. Okay, so this question is also kind of easy. I will just hint you how to do only. Okay, and then you do it by your own. Okay, find the perpendicular distance. So perpendicular distance from the center O to the chord here, 90 degree. Okay, so it will divide this into 2. Okay, so this is 15. This is also 15. And perpendicular distance is this. Okay, I put X. Okay, this is your perpendicular distance X. Or if you don't want X, then put D. Also okay. Okay, so if I put D, so to find D, you use Pythagoras Theorem. Okay, you must use hypotenuse square to minus the other side square, and then you square root. Okay, so same thing goes to part B. Part B here, perpendicular distance is like this, 90 degree. This is your perpendicular distance, and this 22 will divide into 2. Okay, it will divide into 2 when it's 90 degree here. Okay, so this one also you can do by your own. Okay, DIY, do it by yourself. Okay, so I leave it question 3A, B for you. And question 7 also kind of easy. Okay, I will hint you a bit also. Number 7A, the length of ON. Okay, so what do you have here? You have AB equals to BC equals to 80. So meaning to say that your chords of this AB and this BC are the same. Okay, and this is a perpendicular distance. This is a perpendicular distance. This is also a perpendicular distance. So it's 80, so it divides into 2, 40 here, 40 here, 40 here, 40 here. OM is 9. So OM is your perpendicular distance, which is your 9. Okay, so if there is 9, your ON is also 9. Both are also your perpendicular distance. So you already answered your part A, 9 cm. That's it. They are the same. Okay, according to theorem number 2, so they are the same. Find the radius of the circle. So radius of a circle is here. Okay, I will draw it out for you. Here. Okay, let's say the radius is here. You can use this. This one is 9. This one is 40. 40, 9. And Pythagoras Theorem, find OC. OC is your radius. Okay, I think this one also you can do. You do it by your own, DIY. Okay, and then let's look at page 92, number 8. Okay, this one I will teach you how to do. Okay, and if you see this question, do you think that this is theorem number 2? Okay, theorem number 2 tells us equal chords, equal chords. But these two chords, you can see AB and CD, they are different, even though they are parallel. Okay, Now, in the diagram, AB and CD are parallel. These two lines are parallel, but they are not the same length, right? Yeah, if they are not the same length, meaning to say that the perpendicular distance, okay, this perpendicular distance and the other perpendicular distance here, they are not the same length. Not same length, these two, because the chords are not the same. Unless if the chords are the same length, then perpendicular distance will be the same, just like your question number 7. Okay, here 9, here is also 9. Both also 9 because they have the same chord. This one different chord, so different. Okay, so AB equals to 5 cm. So if AB is 5 cm, this one will break into 2, which is 2.5 and 2.5. This is according to theorem number 1, because 90 degree to the center, it will break into half. Okay, it's a perpendicular bisector. CD is 4, so here will be 2, here will be 2, divided by 2. And the radius of the circle is 3 cm. Okay, so where is my 3 cm? My 3 cm is here. 3 cm. Okay, or here also 3 cm because it's also radius. As long as touch from center to the circumference, it will be a same radius. It's a radius. Okay, find the perpendicular distance between two chords. Find the perpendicular distance, meaning to say that your perpendicular distance from here to O and O from the other one, the other chord. This basically this line, this from here to here. Basically this whole line over here will be your perpendicular distance between two chords. Okay, so you have two perpendicular distance in this one perpendicular distance. Okay, one is for here and the other one for here. So you just need to find this one and find the other one, you plus them. Okay, so okay, let's say I put this one as D, this one I put X. Okay, so I find my D first. My D will be, we can use Pythagoras Theorem here. Okay, the triangle is like this, 90 degree, 3, your B, your O, your D, and your 2.5. Okay, so you can use Pythagoras Theorem, 3 square minus 2.5 square, and then square root. Okay, so you square root and then you will get 1, this one you fill in your own, and then you will get 1.6583. Okay, dot dot dot. Okay, and then for X, we have another triangle like this. Your D, this is X, or OD is 3, here is 2. So your X square will be 3 square minus 2 square. So your X is square root of 5. And then you can find it your own, or you can leave it as a as in a square root of 5. Leave it like this also can. Okay, so your perpendicular distance, your total perpendicular distance here, this perpendicular distance between two chords. Okay, I'm talking about this between two chords. The distance, this green line, D plus X. Okay, so it's 1.6583 plus square root of 5, or plus the number that you already square root. Okay, you fill in by your own. So this one you will get 3.8944. So 3 significant figure, because the answer here says 3 sig fig. The question says 3 sig fig, so 3.89 centimeter. Okay, that's all. Okay, so today's lesson, that's it, a very short one, right? Yeah. So lesson 19. Okay, you're gonna do your notes. Don't forget to write down your theorem number 2, and then write down try it 3 and your exercise 3.1 number 3, 7 and 8. Okay, so only this, no worry, no more. So what you're gonna do again, try it 3, you copy questions. Number 3, you only need to copy the circles, okay, and you do it by your own. Number 7, you can draw only the circles and also A and B. the full questions no need to draw, no need to write down. Number 8 also the same, you just need to draw the circle and find out the answer. Okay, you can try it by your own again one more time for yourself. Okay, that's all for lesson 19. Bye!